Hey everyone, this is Brady, the Game Dev Artisan. In this video, we're going to be continuing our series on Godot Fundamentals. We'll be creating a new main menu in which our game will start from, and allow us to start our world or quit our game, as well as introduce some scene transitions when leaving and entering our menus. To get started, we'll be creating our new main menu scene based on a control node. Go ahead and create a new folder within our Scenes UI folder. We'll just go ahead and call this folder Menus. We can save and name this scene main menu. We'll put it inside our UI menus folder. To compose our scene, we'll add a new child node of type color rectangle. We'll go ahead and use the preset for our anchor to full rectangle. And we'll want to give this a nice color. Let's go ahead and give it a text value, give it kind of a dark blue. Next, we'll add a sibling to our main menu. And this will be of type margin container. Again, we'll go ahead and set our anchor preset to full rec. Inside here, we'll change the theme overrides constants so that our margin is the same across all four sides of about 32 pixels. Now for our main menu, we'll be adding a title text, which could be a logo, as well as some options such as our start, game, and quit buttons. To do this, we'll want to align our text using a VBox container node. Inside our layout for our container sizing, we'll ensure that our size for horizontal and vertical are fill. And for our alignment, we'll set it to center. Next, we'll add a child label, which will act as our placeholder text for our title. For our project, we'll go ahead and name this Godot Fundamentals. Now for our label, we'll also want to set our horizontal and vertical alignment to center. And inside our theme overrides, we're going to be changing our font size to about 32 pixels. And inside its layout, we'll go ahead and add to the container sizing our vertical to span to a fill that expands. This will ensure that our label takes up any additional free space that's there. Next, we'll add another child to our VBox that is also a VBox. And this will be the container for all of our buttons. We can go ahead and rename this to Buttons VBox. Now for this node, we should also be setting its layout and container sizing so that it also expands. However, on the vertical, we actually want to shrink it to the end. This will ensure that the buttons stay pinned to the bottom of our UI. Lastly, we can add our child buttons for start game and another button for our quit game. Now we can set our text respectively. For each button, we will set its layout, container sizing to shrink to center on both the horizontal and vertical. Now to improve on our menu navigation, we'll be introducing a new concept of focus. If we look inside of our button, we can see that there's a focus section that describes neighbor positions as well as a next and previous. This allows us to tell Godot when we tab or use the arrow keys to navigate within our UI which element we want our UI to focus on. For example, when pressing down on the arrow keys, we want our start game to be focused, and then from there, its bottom neighbor would be our quit game. Now for wrapping purposes, when we press up on the keyboard, we want start game to also go to exit. Now if you had multiple elements, these would obviously be separate, but in our case, because we only have two elements, they will wrap to the same element. Next and previous would be the same. Great way to think about next and previous is when you press tab, which field should be highlighted next? And when holding shift and tab, which element will be highlighted previously? We'll repeat this process for our quit game button. Great. And we'll see an example of more options when we look at our in-game menu. Now currently, if we look at our font and our buttons, it's a bit of the basic layout out of the box. To improve on this, we can introduce a new theme to our UI by creating a new theme asset. Let's do this by selecting on our main menu, opening our theme section, and inside the theme property, we'll go ahead and select a new theme. If we double click this, it'll bring up the theme editor on our bottom panel. We'll go ahead and save this. Inside our UI, we want to go up to our assets folder, and we'll create a new folder that we'll call themes. And inside here, we'll just name this default theme. Now to improve the font, we'll be adding a new default font type. For my project, I've introduced the early Game Boy by Campbell. You can use whatever font you would like. Link to this is in the description below. Inside our assets folder, we'll create a fonts folder, and we'll go ahead and drag over our early gameboy.ttf file, or whatever your font file is. Then we can drag that into our default font. Once we have that, we can set our default font size. For mine, I'll set it to 16 pixels. And now let's talk about the button styling. If you notice, our button has a bit of a texture behind the text. And we can adjust this behavior inside our theme by introducing an override for our button. We can easily do this by clicking our plus button, selecting the button type, and inside here we have options to override. For example, we can change different colors based on the state of our button. And inside our styles tab, we can also adjust the style box that's displayed for those states as well. For our case, we'll be disabling all of the styles and using the style box empty in all instances. Next, for our colors, we'll be modifying the focus color so that when we've set our focus based on those focus groups, we can see the highlight color change. We'll do the same thing for our hover color, and lastly for when our button is pressed. And you can see inside the preview window for our theme editor, we can see the behavior of our buttons on the left. This is a very simple theme that we've set up, but it should work for now. And if we look at our main menu, it should look something like this. Now that we have our visuals taken care of, let's add some signals and wire up how we want to interact with this scene. A practice that I've found works well with menus is that I'll set up the scene to handle button presses as normal, and that the root node will delegate the intended behavior to the outside world. This defines somewhat of a contract. For example, we have two outcomes in this scene: to start the game or to exit the game. Here we can have our main menu scene emit a signal when we want to start our game, and for our exit game, we don't need to notify of this intent. We can just tell the scene tree to quit. So let's set up our main menu script. We'll attach a script here, make sure it saves in the UI menus folder, and create that. Go ahead and define that we're going to be using a signal called start game. And here we'll define two functions that will be used as our handlers. We'll have one for on the start game when our button is pressed. And here we're going to emit the start game signal. And we also want to have the behavior of hiding our main menu once we start the game. Next, for when we want to handle our on quit button pressed, we're going to take our scene tree. We're going to call quit. Now this is a great start, but it's a good example of adding additional behavior to a specific signal that we're handling. Sometimes you may want to handle a signal and do other behavior before emitting out to your other contracts with other nodes. We'll look at that in the game scene here shortly. Another thing that we can introduce here is the expected default focused button. We can add a new function that handles focusing a button for us to use and call it when our node is ready, as well as whenever the menu comes back into visibility. For example, let's take our buttons VBox and give this a unique access name. And once we've done that, we can click and drag this and create a reference within our script. We'll create a new function to handle whenever our visibility changes. If we are visible, we want to call a new function called focus button. Now this focus button function is going to check if we have a reference to our buttons VBox. And if so, we're going to get the button from the first index. So this should be our first button element. And if it is in fact a button, then we will call our buttons grab focus. Now for this focus button function, we can also call this in our ready state. This means when our menu is first ready, we'll focus on the right element, as well as when our menu hides and unhides, we'll make sure that we refocus that initial element. Now let's open up our UI scene, and we'll integrate this new main menu into the scene tree. We'll be leveraging our UI script to wrap our expected contract of behavior for when our main menu signals are emitted and the behavior that we expect at the UI layer. For example, when we select our start game from the main menu, we want our UI layer to play a transition, and meanwhile, we want to inform our game scene that we want to populate the world and get the game started from there. So inside our UI scene, we can add our main menu to our control node by creating an instantiated scene from our menus with the main menu. Now we'll also give this a accessor for a unique name. Inside our UI script, we'll bring a reference to this and bind it here. Now inside our UI, we'll be creating a signal for when we start the game. And it's important to note that we will want to wire not just by naming the functions, but also adding the connections to those functions as well. So inside here, we can create a new function that we'll call onMainMenu, start game. Here we will call the emit function on our start game signal. And again, inside our node, we'll want to make sure to wire up that our main menu goes to our UI function. Once we've done that, we should have our icon indicating that this signal is connected. Be sure if we go back to our main menu that we do the same thing for these signals as well. Again, we can select our start game, pressed, make sure it's connected to the main menu script. And for our pressed, we'll use the onQuit button. Lastly, for our main menu, when the visibility changes, we'll call our self and connect that on visibility changed. Notice that we had a typo where we missed the I. The keen among you may have already noticed. So we'll just copy the functionality, move that here, and replace that function. Perfect. Now back in our UI script, we can see that this just emits the signal when we capture that the main menu button has been pressed. Again, this is similar to mirroring the signal. However, we will be adding additional behavior that's handled inside our UI layer as well. We'll come back to this. For now, let's open up our game scene and modify our behavior for what our game should do by default. Again, our game acts as a wrapper for the behavior of both our menu as well as our world scene. Because our game no longer jumps directly into the world with our tank, and instead will start with our main menu, and our signal will indicate when to start our game. Because we'll be using that signal to call the function, we don't want to call our start game from inside our ready function, nor are we going to have access to our tank right away. To begin, we'll delete our world and tank scenes from our game, which if you note, will break our export variables for our game, as well as the target export for our camera. To resolve this, inside our game script, we'll create an export variable for our tank scene of type pack scene, as well as an export variable for our world scene of type pack scene. And we'll take our tank out of the exports and we'll move it down to an internal variable. We'll create tank and world as local variables. Now we can refactor our start game function to instantiate the tank and world scenes and allows us to completely eliminate the need for this ready function. To start, we'll set our world equal to our world scene, instantiate it. Then we'll add a child of our world to our current game scene. Now for processing, we would like to move the child node of type world to the first child index of our game scene. This is important because of the way that the game processes the individual nodes. Next, we'll take our tank and set it equal to an instantiated version of our tank scene. And here we'll go ahead and add it to our world scene. Next, we'll set our tank's position to somewhere within our world using the vector 2. And then we can explicitly set our connections between the signals of our tank and our UI. Similar to our previous start game, we'll make sure that our tank does not have current control. We'll also want to set that our camera is now focusing on this target. And then we'll continue with our create timer and camera-based behavior afterwards. We can actually remove this call as we're doing it shortly after. Otherwise, it's redundant. And now that we've moved all of our connections, we can go ahead and remove this function entirely. It's important to note that our camera being changed to our target tank is no longer happening when it's initialized. So inside our camera scene, we'll also want to add a override to our target setter function that when the target is set, we will be also setting our fallback target equal to that target, but only if our fallback target is already null. Otherwise, we'll just keep it as our current fallback target. Then we'll set our target equal to this new target. This replaces the current ready function call to set our fallback target by default. Now back in our game, we can go ahead and attach to our UI the start game signal. Inside our start game, we're going to call our start game function. And if we test, we can see our new main menu is our default entry point for our game. We use our arrow keys or our tab button. We can see that our focus is working. And if we start our game, we're met with an error because we did not set our world scene or our tank scene within our game's exports. Back to our inspector, we can open up our scenes, open up our world scene and drag it to our property. We'll do the same thing for our tank entity. And if we rerun, start our game, we'll notice another typo. It is reload progress instead of reloaded progress. Go ahead and rerun that. Start our game. And there we are. Our game starts up. The tank is instantiated and dropped into our world. The camera properly attaches to our target. And the scene transitions as it's expected to. Now we have a basic in-game menu. Let's go ahead and add some improvements to this. Back in our UI, let's go ahead and take our in-game menu and extract this to its own scene. Save branches scene. Put this in our scenes UI folder for our menu. We'll call this one game menu. And inside this scene, we can rename this to game menu. And inside our margin container where we have our VBox container, let's go ahead and do the same thing here and call this our buttons VBox, as it contains our grid buttons for our sliders, but also will contain our new returned game, returned menu, and quit game buttons. Let's go ahead and add those children. Button. We'll call this first one the return to game button. And we'll slide this to be above our grid container. Next, we'll add a child button. We'll call this the main menu button. And last, we'll add button. We'll call this quit button. Go ahead and set their values in the text. Here we'll call this continue game. Main menu, we'll say return to menu. For quit, we'll just say, you can see this visualized here in our 2D view. Make sure this is not hidden. Again, we can bring our UI theme from our themes folder, selecting our control node and dragging over our default theme. This updates our buttons as well as our font. Back to our buttons, we'll select all three. And for our text behavior, we'll set our alignment to be left aligned to better fit our menu. Next, we'll improve our navigation further by introducing the focus groups for our focus neighbors and our next and previous buttons. Starting with our return to game button, we'll open our focus. And if we look at our navigation, we want our continue to go to our quit game when we go up. So we'll go ahead and select quit button. When we go to the neighbor down, we're going to go to the music slider. When we go next, also be the music slider. And when we go previous, we'll go back to the quit button. We'll do the same thing for our music slider. Open up our focus, Top is going to be our continue button. The bottom is going to be our sound effects slider. Our next is going to be the sound effects slider. And our previous is going to be the continue button. Just continue repeating this for all of our buttons. Great. Now it's important to note that because we migrated from our UI scene, that our game menu and the audio sliders need to also be moved into a new script for our menu. Let's go ahead and attach a new script. Make sure it saves in the same folder called gamemenu.gd. And here, we'll take the corresponding UI components, such as our music slider value changes and our sound effects slider changes. We'll bring these functions into our new game menu script, as well as our constant definitions that we call onReady. We'll also want to bring over our buttons VBox as a reference. And similar to our main menu, where we leverage the focus button function, we'll bring this over as well. Again, we can tie back in our music slider for when the value is changed. Make sure we have our signal showing it's connected. Do the same thing for our sound effects slider. And for our new focus button function, we'll want to make sure that when our game menu has its visibility changed, we're going to check if we are visible, and we're going to call our focus button. Next, we can set up our functions for the return to game, main menu, and quit button when they are pressed. Just like we did with our main menu, we'll be creating new signals that control what our behavior should be based on a signal from the underlying buttons being pressed. We'll have a return to game signal, main menu signal, and again, when our quit button is pressed, we will just take our scene tree and we'll call quit. Our main menu will emit, and for our return to game, we will emit. Now we can improve our UI by updating its functionality based on our game menu. We've already bound a reference to our menu here. So inside our input function, we'll be updating its behavior. So first of all, check if our main menu is visible. And we don't want to toggle when we press the escape key or UI cancel key. And if our menu is visible after we've inverted it, we're going to call a new signal, menu opened. We're going to emit that. Otherwise, we'll emit a signal that our menu has been closed. Again, this allows our UI to communicate to our game scene. Let's go ahead and create these signals at the top. And we'll also be emitting a signal when we want our UI to quit back to the menu. This will be able to indicate up to our game scene that it needs to destroy the world scene. Let's go ahead and hook up our menu's new signals for the main menu, as well as our return to game menu. Inside our main menu, we'll be taking our game menu and hiding it. And then we'll be quitting to the menu by emitting this signal. And then we'll take our main menu and show it again. And when we return to the game, we'll hide our menu and make sure we emit our closed signal. Now with our new signal that we added for quit to menu, we'll want to link that into our game scene. So back to our game scene, we'll select our UI, we'll add a quit to menu link. And when our UI calls the quit to menu, we'll check for our world. And if it exists, we'll tell it to queue it free. Then we'll set our world variable to null. Then we can set our tank equal to null. And our camera, we will call a reset function. Back in our camera, create this function called reset, sets our target back to null, and also, very importantly, the fallback target back to null. This should bring our camera back to its default settings. Great, let's give this another test. We go to start game. You can see it brings us directly into our game scene. Note that our game menu is visible by default, we notice we can't select any of the values within our scene. We return to our UI layer and look at our composition. Even though our main menu is hidden, one important note about hidden elements in a UI is that the mouse input processing is being filtered to stop at our main menu. This is fine when our menu is visible, as we don't want to click on the elements below our menu. However, we want to ignore or pass anything that we have to the underlying elements. Also note that our letterbox exists, and it has the same issue. Because our letterbox isn't actually needing any of our mouse input, we can set it to ignore. And if we rerun our game, press start, we can see that our hover icons are working, and our arrow keys are properly toggling, but we notice that it didn't grab focus initially. That's because we're relying on visibility changes. Let's go ahead and quit, return to our UI, make sure that by default our menu is hidden, rerun our game. Now when we start, we can confirm that by pressing escape, brings up our menu, and by default, we have our focusing. Now that we are opening and closing our menu in game, we want to be able to pause our game to prevent any movement in camera from panning around. Now to pause our game, we must first define which of our nodes should respect our pause state, and also which of our nodes we will allow to continue processing as usual. You can read more about the processing games and process mode on the Godot documentation page, linked in the description down below. To leverage this built-in functionality, we can simply go to our world scene, selecting our world, and inside its process, we'll set the mode to pausable. Next, inside our UI scene, we'll make sure that our control nodes are set to their process mode to always. The different modes describe when the process function should run. A pausable mode allows it to stop processing when our scene tree is paused. Always tells it to continue processing in all conditions, ignoring the scene tree's pause property. A good example is if we look at our game and look at our audio stream player. This is our background music. If we want this to play all the time, even when our menu is paused, we can select our process mode and also set that to always. Then in code, we can set our UI to toggle the scene tree's pause state when we start our game and when our layer decides to open and close a menu. Inside our game script, we can come down to our start game. Just after we change our target, we'll go ahead and get our tree and set the paused state equal to false to make sure that we're not paused once our game is set up. And here inside our game, we'll make sure that our UI has the new menu closed and open signals connected. And when it closes, we'll make sure that the pause state is set back to false. And when the menu opens, we'll make sure that our pause state is set to true. Now to test our pause state and rerun our game, start our game, we'll notice that our camera is following. Our scene does its transition. And if we press escape and move our mouse cursor, the camera is no longer following our mouse cursor, and our turret is no longer following the cursor as well. We continue our game, it snaps back and processes. And if we fire around and press escape, we can see that it pauses the processing of both our sound effects as well as our icon moving across the screen for our bullet. When we continue, we have our collision. Great. Now last, let's set up a transition animation between our scene changes. Inside our UI scene, we'll add a new child to our control node. This will be a type of color rectangle. We'll go ahead and call this transition. And we'll go ahead and give this a color of solid black. And then inside our animation player, we'll go ahead and create a new animation that we'll call screen transition. And here we're going to track the property of our new transition, and we'll be modifying the canvas items modulate property. Here, we'll make sure that the transitions modulate property, which is part of the visibility section of a canvas item, We'll keyframe the solid white by default. And we'll drag our track to the end of the animation. We'll modify this to a fully transparent, and we'll keyframe that. We'll also be modifying the first frame's easing to a 2, which will ramp the transition further and faster as it gets closer to the end of the animation. Go ahead and save that. And within our UI script, we'll be calling our animation player to play our new screen transition at the right moments. Also, let's go ahead and add a unique access name to our transition, and we'll bind a reference inside our script. All right. And down in our start game, when we admit that our game should start, we're going to call our transition to show. We'll tell our animation player that we want to play the screen transition. Next, we will await for that animation player to finish its animation. Once that animation is finished, we'll take our transition and we'll go ahead and hide it. Next, inside of our main menu, before we do anything, we're going to check if our animation player is currently playing an animation. Then we're going to wait for that animation to finish. Then we'll hide our menu, and we'll take our transition, we'll show it, and in this case, we're gonna play our transition backwards. Wait for that animation to finish. Then we'll hide our transition. And from here, we'll be back to our main menu, which we can show. And in the case of returning to the game, we're just gonna make sure that if an animation is currently playing, that we await for that animation to finish, then we'll hide our menu, and then we will close with our emit. And if inside our animation player, we can preview, the transition is available. And a very important aspect, make sure that you set your anchor preset to extend across the full rectangle so that it covers the whole screen. If we toggle our visibility to hide our transition and run our game, you can see our nice fade in. And when we return to the menu, our animation doesn't play. Now it looks like part of what's happening here is when our UI is pausing, we forgot to set our UI layer as a whole to the mode always. Mistake that we made was on our UI layer, we set our control to always process, but it needs to be the underlying UI layer set always. If your game was freezing when you tried to return to the main menu, that might have been your problem. Test again, press start, wait for our camera transitions, return to the main menu, and we see our transition back to the main menu. We can then start our game back up, transition back in, and our camera scene takes over. And there you have it. We've successfully created a menu with a scene transition using the animation player to customize the way we want our animation to behave when we go from one scene to another. And because we're using the animation player, you can create a variety of different transitions between scenes to match your look and feel you're going for. And our menus demonstrate a great way to utilize scene composition to allow you to change the state of your game depending on the context that you're trying to go for, whether it be from a menu or to a world. And this same concept can be used to change levels, enter and exit different zones, or to completely restructure the scene tree within your game. And let me know down in the comments below how you would utilize this type of scene composition in your game. And if you found this video helpful, please leave a like. And if you aren't already, please do subscribe, as it does help support the channel. And if you'd like to have a deeper discussion, check out my Discord channel linked in the description down below. And as always, thanks for watching and happy coding.